Hello, good morning, everyone. Back to our math class again. Last week, we looked at the first part of polynomial. In that, we look at the definition of a polynomial. We look at the basic arithmetic processes in polynomial, where we look at how to add polynomials, how to subtract, how to multiply and divide. We went further to look at the algorithm. Under the algorithm, we look at the synthetic method and the long division method. You can see it in the material that we looked at last week. We see here we use the long division method in this. Let me scroll up so that you understand what I am saying. So this place we use the synthetic method. We use synthetic division method to obtain the quotient and the remainder. So today we'll be starting from the remainder theorem. Remainder theorem. Under the remainder theorem, whenever we divide a polynomial p of x by x minus c, we always get some quotient and a remainder. And that remainder is represented with letter r. And p of x will be equals to x minus c, q of s plus r. When we set x to be equals to c, it means that equation 1 will reduce to p of s equals to what? R. Because that will give us x minus x, q of x. X minus s will give us 0. And as we know in mathematics, any number multiplied by 0 is 0. So p of c will be equals to r. In this case, r, as I have said, stands for our what? Remainder, while c is the value we have. So whenever you substitute the value c in a given polynomial, you will have what? The remainder. From equation 2, we have that whenever p of s is divided by x minus c, the remainder is p of c. So that is what the theorem we have under it is saying, that whenever a polynomial p of s is divided by x minus c, then the remainder is p of c. So this is what we'll be using to solve questions before we go to the other subheading. Question number 1 says, find the value of k if the remainder, or the value of k if the remainder when p of x, which is equals to 2x raised to power 4 plus kx raised to power 3 minus 11x plus 4x plus 12 is divided by x minus 3 is 16. In this case, if you compare it to this equation that we have above here, you see that the c in this question is 3 and r is 16. So we'll go down to the solution now. P of x equals to 2x raised to power 4 plus kx raised to power 3 minus 11x squared plus 4x plus 12. Now, when you substitute the value of p of s it will be equals to 60 according to the theorem I just explained. So p of 3 is equals to 2, the coefficient of s raised to power 4. X now is 3 raised to power 4 plus k, 3 raised to power 3 minus 11, 3 raised to power 2 plus 4 times 3 plus 12. If you sum up this, it will give us 87 plus 27k. And we know that the remainder is 16. So that is why we have 87 plus 27k equals to 16. If you collect like terms, you have 27k equals to minus 27. So if you divide both sides by 27, you have your k to be equals to what? Minus what? 1. It means that the polynomial given above, when we substitute the value of k, it will give us 2x raised to power 4 minus x raised to power 3 minus x raised to 11s squared plus 4s plus 12. In case you are asked to find a polynomial, because in some cases you might be asked to even go further to find the zeros or to factorize the polynomial. Now we come to example 2. Find the value of k for which the polynomial p of s equals to x raised to power 5 plus ks raised to power 4 minus 2s plus 1 leaves a remainder of 5 when divided by x plus 2. In this case, if you pick your x plus 2 and equate to 0, it will give you the value of your c to be minus 2. So that is why we have p of minus 2 equals to 5. So if you substitute the value of p equals to minus 2, you have 16k minus 27. And this you will equate to the remainder, which is 5. So that is why we have 16k minus 27 equals to 5. Again, if you collect like terms, you are going to have 16k equals to 32. Now, if you divide both sides by 16, you have your k to be equals to what? 2. Example 3, a polynomial p of s is equals to ax raised to power 3 plus bx raised to power 2 minus x plus 3 has factor x plus 1, and when divided by x minus 4, leaves a remainder of 15. Find the value of a and b and factorize p of s completely and also obtain what? The zeros. Now we come to the given polynomial p of s equals to ax raised to power 3 plus bx raised to power 2 minus x plus 3. Now if you pick the factor which is x plus 2 and equate it to 0, the value of your x will be equals to minus 1, or which is also equals to the value of c. So if you substitute p of minus 1, the remainder is 0. So p of minus 1 will give us this expression, a into minus 1 raised to power 3 plus b into minus 1 raised to power 2 minus into minus 1 plus 3. So this a raised to minus 1 raised to power 3 will give us minus a. This minus 1 raised to power 2 will give us plus b. Minus times minus will give us 1. 1 plus 3 will give us 4. So that is how we got this minus a plus b plus 4. And this one, if you equate it to 0, it will give you a minus a plus b equals to minus 4. Now, the second part of the equation says that if we use the factor x minus 4, the remainder will be 15. So that is why we have p of 4 equals to 15. Now, if you substitute the value of p of 4 equals to a into 4 raised to power 3 plus b into 4 raised to power 2 minus 4 plus 3 equals to 64a plus 16b minus 1, and this is equals to 15. That will also lead to another equation again, 4a plus b equals to 11. Now, when you solve these two equations simultaneously, it will give us the value of a equals to 1 and the value of b to be equals to minus 2. Now, if you look at a and a in equation 1 is minus a in equation 2 is 4a. But you look at b in equation 1 is just b with a coefficient of 1, and that of equation 2, b has a coefficient of 1 also. So you can subtract the two equations. That is minus a minus 4a will give us minus 5a, minus 4 minus 1 will give us minus 5. So that will give us minus 5a equals to minus 5. So you divide both sides by minus 5, it will give us a to be equals to what? 1. If you substitute the value of your a in either equation 1 or 2, you get the value of your b to be equals to minus 3. So now, if you substitute the value of your a and b in this polynomial, that is p of s equals to ax raised to power 3 plus bx raised to power 2 minus s plus 3 is equals to a raised to power 3, because your a is 1, minus b is minus 3. So that will now give us minus 3 raised to power 2 minus x plus 3 equals to 0. So this one we'll factorize it. If you factorize it, you are going to have x minus 1, x plus 1, x minus 3. And when you equate it to 0, it will give us x to be equals to 1 from the first bracket, x to be equals to minus 1 from the second one, s is equals to 3. So that the zeros of the polynomial are x equals to 1, s is equals to minus 1, and s is equals to what? 3. So that is how we find the zeros of a polynomial. Now, example 4 says, find the value of a and b, for which the polynomial p of s equals to ax cubed plus bs squared minus 3s minus 4 leaves a remainder of 35s minus 32 when divided by s squared minus 3s plus 2. So if you look at this, if you divide as cubed plus bs squared minus 3s minus 4 by s squared minus 3x plus 2, it will give us the quotient plus the remainder is 35x minus 32 divided by x squared minus 3s plus 2. Now, ax cubed plus bs squared minus 3s minus 4 is equals to x squared minus 3s plus 2, bracket open and close, q of s plus the remainder. Now, as cubed plus bs squared minus 3s minus 4 is equals to as squared. The factor, when you factorize this quadratic expression, it will give us s minus 2, x minus 1, q of s plus the remainder, which is 35x minus 32. Now, in this case, if you set your x to be equals to 1, from the left-hand side, you have your a 1 raised to power 3 plus b 1 raised to power 2 minus 3 times 1 minus 4. This one will be equal to 35 times 1 minus 32. So if you look at it from the left-hand side, you have your a plus b minus 7 equals to minus 7 equals to 3. So if you collect like terms, you have a plus b equals to 10. Now again, if you set your x to be equals to 2, you have, for the left-hand side, you are going to have 8a plus 4b minus 6 minus 4. It gives us 35 times 2 minus 32. So we have 8a plus 4b minus 10 equals to 70 minus 32. So if you divide by 4, you're going to have 8a plus b equals to 12. Now you also solve the two equations simultaneously. If you solve the two equations simultaneously and using the method of elimination, you have a equals to 2 and b equals to 8. In this case, you now go back again after you have gotten the value of your a to find the value of your b. You can use either equation 1 or either equation 2 to get the value. Example 5 says a polynomial p of s is equals to s cubed plus ax squared plus bs plus 6 has a remainder 4 minus 4x when divided by x squared minus 3s plus 2. Find the value of your a and b. So we have this using the log division method. S cubed, the first one here, divided by the first one here, that is s cubed divided by s squared, will give us x. So x times s cubed will give us s cubed. X times s squared, will give us s cubed. X times 3 minus 3s will give us minus 3s squared. X times 2 will give us 2x. If you subtract the 2, that's this first one from the second one, you're going to have a plus 3 x raised to power 2 plus b minus 2 multiplied by s plus 6. Now, if you pick the first one here, a plus 3 s squared, and divide it by s squared, you are going to have a plus 3. Now multiply this a plus 3 by this, it will give us a plus 3x squared, the first one here, minus a plus 3 minus 3x plus a plus 3 times 2. So if you subtract, you are going to have 3a plus b plus 7s minus 2a. So that will lead us to 3a plus b plus 7s minus 2a equals to the remainder, which is 4x plus 4. So when you compare the coefficient, you see that 3a plus b plus 7 is equals to minus 4. On the other one, minus 2a is equals to what? 4. So minus 2a equals to 4 will give us the value of a to be equals to minus 2. Substitute the value of a there to be minus 2. That will give us minus 6 plus b plus 7 equals to minus 4. It will give us the value of our b to be equals to what? 2. So that is how we find the value of a and b in that question. Now question 6, you study it yourself. The question says, the remainder when the polynomial p of s is equals to 4s squared plus as squared plus bs plus 8 is divided by 2s squared plus s minus 1 is 8x plus 5. Find the value of a and b. So you study that one yourself, follow the one I have explained. You will be able to understand how we get all these values. Now we'll come to example 9. The expression ax cubed plus bx squared plus cx plus 6 is divisible by x minus 1. It has a remainder minus 4 and 18 when divided by x minus 2 and x minus 4 respectively. Find the value of a, b, and c. So from here, this is the given polynomial. When x is equals to 1, the remainder is what? Is 0. When x is equals to 1, we now have a plus b plus c equals to 6, which give us the equation a plus b plus c plus 6 equals to 0, equation 1. Now, when we substitute the value of x is equals to 2, the remainder is minus 4. And p of 2, when the value of s is 2, will give us 8a plus 5b plus 2c. And this one will be equated to what? Minus what? 4. That gives us equation 2. P of x equals to 4 will give us a remainder of 18. P of 4 will give us the equation 3. So these three equations, you now solve them together. And you have the value of your a equals to 1, the value of your b equals to minus 2, and the value of your c equals to minus 5. So we have two questions here. Find the remainder when p of s is equals to 3x raised to power 100 plus 5x raised to power 85 minus 4x raised to power 38 plus 2x raised to power 17 minus 6 is divided by s plus 1. The question 2 says, find the value of k for which x raised to power 5 plus 4x raised to power 5 plus kx raised to power 4 minus s squared minus 3s plus 1 leaves a remainder of 3 when divided by x plus 2. So those are the exercises you need to practice before we meet physically upper week at Omoya. Now we'll come back to another theorem which is called the factor theorem. Under the factor theorem, when we divide the polynomial p of x by the factor x minus c, it gives us a quotient and a remainder r such that p of s will be equals to x minus c, p of s plus r standing for the remainder. If we now set our remainder to be equals to 0, it means that p of s will be equals to x minus c the times q of x. Equation 2 implies that when the factor x minus c of the polynomial p of x is equated to 0, x will be equals to c. And when x is equals to c, equation 2 reduces to p of c equals to what? 0. So that is the summary of the theorem. A polynomial p of s has a factor x minus c if and only if P of S is equals to what? 0. And that is what we call the factor what? Theorem. That is what we call the factor theorem. Now we'll come back to example 1. Example 1 say for what value of A is x plus 1 a factor of P of S equals to 2x raised to power 4 plus 2x raised to power 3 plus ax squared minus 3x plus 2. Now we know that if we substitute the value of C, the remainder is 0. That is why we say P of minus 1 equals to what? 0, because C, as far as this question is concerned, is minus 1. Because if you pick this x plus 1 and equate it to 0, it will give you x to be equals to minus 1, which is the value of your C. So P of minus 1 is equals to 0. And if you substitute x to be equals to minus 1, we're going to have A plus 5 equals to 0, which means that A is equals to minus 5. Now we'll find the value of A which makes 2x minus 1 a factor of P of x equals to 2x raised to power 3 plus x, ax squared minus 13x plus 6. Again, if you pick this factor 2x minus 1 and equate it to 0, you are going to have 2x to be equals to 1. And that 2x equals to 1. If you divide both sides by 2, you have x to be equals to 1 over 2. So that is why in this place we have P of 1 over 2 to be equals to 0. P of 1 over 2, it will give us 1 over 4a minus 1 over 4 equals to 0. If you multiply through by 4, it will give us a minus 1 to be equals to 0. If you make a the subject, you have a equals to 1. Example 3, when is x plus 4 a factor of P of s, x cubed plus x squared plus ax plus 8. Now, when you pick that factor x plus 4 equal to 0, it will give us x to be equals to minus 4. And P of minus 4 is 0. Substituting the value of s equals to minus 4, it will give us minus 4a minus 4t equals to 0. So, taking minus 40 to the other side, you have minus 4a equals to 40. Dividing both sides by minus 4, it will give us a to be equals to minus what? 10. Now we have the question under it again. Determine the value of k so that P of s, which is equals to s cubed plus ks squared plus ks plus 3 is divisible by x plus 3. Show that x plus 2 is a factor of x raised to power 12 minus 4096. For what value of m is P of s equals to s cubed plus 3s squared minus s plus m divisible by x plus 8. So we'll stop the class at this point. When next we meet, we will be looking at a new topic. And that topic is I think we'll look at binomial theorem before we come to partial fraction. So we're calling it a day at this point. For those of us that are just joining us, it is expected of us to mark the attendance, write your name and your department, and send it to us through the chat box. We'll collate it and it will be used as your attendance. Looking forward to meeting you at Umuya upper week by the grace of God. Bye-bye at this point.